Hey, welcome to my YouTube channel. In this tutorial, I will explain the PCA or the Principal Component Analysis and its implementation. Afterwards, I will use the PCA transform data for classification using the SVM model. Let's get started. Okay, now first let's see what are dimensionality and projection. Dimensionality is the number of features in the training dataset. And to understand the projection, we have to use these images. So this is a three-dimensional space having our data in higher dimensions. So what PCA does is that it tries to find the best hyperplane which goes through the data so that the distance between the plane and each and every point of the data is minimum. And after finding such a plane, it projects the high dimensional data onto this lower dimensional hyperplane, just like this image. So now this is the converted data, and it has been converted from 3 dimension to 2 dimensions, which are Z1 and Z2. The Z1 and Z2 are also called the components, which is the linear combination of all the features into the high dimensional dataset. With all that clear, now see the definition of PCA. It is a dimensionality reduction technique which transforms the high dimensional data to lower dimensions by finding the best hyperplane in lower dimensions, and the components it produces are the linear combination of all the features, and the components are orthogonal to each other. I hope now you have a better understanding of PCA. Now let's see its implementation. As usual, I import the following libraries: NumPy, Pandas, PyPlot and Seaborn. Afterwards, I load the dataset. This is the standard dataset present in the Scikit-learn dataset repository. This dataset is present in the form of a dictionary where different keys hold the different information about the data. So let's have a look on its keys, which are data, target names, description, feature names and file name. So the data key hold the entire data, and the target hold the target classes for which we have to predict which type of cancer the data represents, then the target names, and so on. Let's have a look on the description of the data. So now here you can read more about the data. So basically we have to predict between the 2 types of breast cancer, which are malignant and benign, and also see the feature names. So these are all the feature names which are present in our dataset. These are all the columns, and which are 30 in number. So our dataset is fairly large as far as the dimensionality is concerned. Let's convert the data into a Pandas data frame with provided feature names, and our dataset will look like this. It has 30 features. Now let's standardize the data. Sometimes this is the crucial step when we have the values in different scales, like we have a value 10 here and here is 122. Here we have a big difference between the values, and similarly this value is very small compared to the 122. So we have to bring all these values down to the same scale, which is done by the standard scalar class of Scikit-learn pre-processing submodule. So here I am making an object of standard scalar class and calling the fit transform method on data frame values using the SC object, and first import this, then print the first observation. So now our data has been converted like this. So all the values now have come to the same scale. Now it's time to apply the PCA. First, import the PCA which is situated in the Scikit-learn decomposition submodule. After that, I create a PCA object out of the PCA class by specifying the number of components we want to have. Here I specify the 2 components which will be orthogonal to each other. After that, I call the fit transform method on X, and the transformed data of 2 components will go under the XPCA variable. Let's see its shape. Okay, now previously we had 569 rows and 30 columns. Now we have 569 rows which are same as before, but here we have 2 columns. Remember previously it was 30. So now our data has been successfully transformed into lower dimensions from higher ones. Let's visualize this data using scatter plot by running the cell. Okay, now you can see both the components which are highlighted according to the target variable. So here you can see the orange ones belong to the class 1 and blue ones belong to the class 0. So it has been converted into 2 components. This is the first component, this is the second component. So as you can see, that the data is clearly separable by a line here. So it is a good choice to use the support vector machines algorithm to classify this data. As I previously said, that a component is a linear combination of all the variables of the high dimensional dataset. So this PCA.components underscore will give those 2 components and the coefficient of the linear combinations of all those features. After that, I convert this data again into a pandas data frame to get a better visualization over it. So here you can see this is the component 1 and this is the component 2, and these are all the features, and these values represent how much that column contributes to that component. So have a look at those values. We can see mean fraction dimension contribute very less to the component 1 and component 2. Now having another visualization over the data. So this is component 1, this is component 2, and this is a heat map, and these are feature names. Darker the value, greater the contribution of that variable into the component. So the most dark value here is the mean fractal dimension. So this column contributes highest in the component 1, and into this the column worst concave points contribute greater in the component 0. So being done with the visualization here, now we can apply the support vector machine classifier onto this newly transformed data. First, let's import the SVC class of the scikit-learn SVM submodule and the train test split function of model selection submodule to test in training sets. Here it takes some parameters out of which test size is the crucial one. Here you can specify how much percentage of data you want to keep for testing. So here I keep 25% of data for testing. Now making an object out of the support vector machine class or the support vector classifier class and fitting on X train and Y train. So now our model is ready. It's time to make prediction. So by calling the predict method over the classifier using the X test will give us the predictions. Okay, now we have the predictions in our hand. It's time to evaluate our model. So to evaluate our model, we need a few things, which are confusion matrix, classification report, and accuracy score. Let's see what are these. First, check the accuracy, which is 95%, and then checking the confusion matrix. This matrix shows that our model has predicted 50 correct values which are previously true and turns which are actually true, and our model predicted them true also. And these are the 86 false, actual false values, and our model predicted them the false also, and these are the wrong values. total 7, 4 plus 3. So our model did a great job at classifying both the classes which are malignant or benign. Then finally printing the classification report, which contain the three metrics: precision, recall, and F1 score. The F1 score here is the most important out of these. So it says that category 0 has a F1 score of 93 and category 1 has a F1 score of 96, which are great values. So the implementation is complete now. Well, it was a great success. Our model achieved over 95% accuracy. So this is the complete implementation of PCA along with the classification. If you find my work helpful, please subscribe the channel and like the video. Thank you.